Unit 6. We are still on 6.1, Part 3. And now we're going to look at logs, and the long word for that is logarithms. Now, logs are literally the inverses of exponents, but also logs are another way of writing an exponential equation. So if I have, and this is important that you learn this, if I have y equals b to the x, so what you have to see is something equals something to the power of something. If I write exactly the same thing but in a different form, then I would write log base b of y equals x. Right, why do we want to write it in two ways? Well, if I have an equation with exponents, do I want to solve for y or x? So if I have the values of b and x and I want to get y, then obviously I use the first equation, because if you solve for, remember you're transposing, then the one you want has to be alone on the left. But if I have the values of y and b, and I want to find the value of x, then I've got a problem with the x being up in the air there. So I've got to bring it down to the ground. Right, I'm going to show you a little rhyme, but I'll do it on the hand of an example. If I have log base 3 of 81 equals 4, and this if and only if just means you can go in both ways with this rule. If I want to take the log away, if you take the word log away, can you see I'm going to call the 3 the little one. Okay, let me write the rhyme for you. The rhyme says the little one jumps across and kicks the other one up. So this is your rule for when you take away the log. So if I take the log away here, then the little one, which is the 3, jumps across. So what will be left on the left? Just the 81, then the equal to. The 3 jumps across and it kicks the 4 up. Right, let's look at this again. Let's just use completely different letters here. So if I wanted to solve for Q, so I had the value of P and I had the value of R, but I didn't know what Q was, I would say if I take log away, then the P is the little one, so it jumps across the equal to and it kicks the R up. Now notice you can actually, if you know your rule, you can actually do it backwards too. So, in this equation, I have the value of the 5 and the 2, but I want the x. So I say to myself, well, if we use our rule backwards, which one was the little one? it must have been the 5 because it kicked the x up, right? So the x would slide back to its place. The 5 will become the little one, but it can only be the little one if I put the word log in front. And this you can do on your calculator. Most of you on your calculator have a button in the shape log with a little square there and a little square there. So this is your base. Your base is a little bit below the line of the book. Can you see that? When you write this on lined paper, it's a little bit below there. Okay, let's do another example of a question. The question would say, solve for x when e to the 3x equals 2. Right, I want the value of x, but the x is up in the air. To allow it to slide down, I have to introduce a log here and let the e, which was the little one, slide back down there. But now here's some news for you. Log base e, remember we said e was the natural function, the natural exponential function. So log base e is the natural logarithm. So we write it like that, and you do have a calculator button for that too. So it's not an I and an N, it's an L and an N. So you just press the ln2 and it will give you 0.69. Remember now it was 3x was equal to that. So x is 0.23. Right, so ln, you pronounce it ln, but you just write the L in the N. So the N is for natural logarithm. So you have a button for that on your calculator once again because we use it so much. So you have to know this rule about how to go from the one to the other. It always depends on which one you need. I'm just going to draw a very rough graph of a basic log function. It's the inverse of the exponential function. So where your exponential function had a y-intercept of 1, you now have an x-intercept of 1. Right, so this is very important because it always depends which one you want to solve for, which that's the one you want alone on one side of your equation.